Hello, today we're going to look at Newton's second law. What we're going to do is we're going to apply a force on this coat. And when we apply a force, measure the acceleration. And using the acceleration, we're going to try to find the theoretical value of the mass. Now for part A, this coat has a mass of 0.213 kilograms. So we're going to try to find that experimentally. Once again, by applying a force, measuring the acceleration, and using the sum of forces is ma. F equals ma, Newton's second law. Now for this first part, everything is perfectly horizontal. And how we're going to apply a force is we're simply going to pull on this coat with this string. But we don't want to just pull arbitrarily. What we're going to do is we're going to put the string over this pulley and hang mass. If we have a mass hanging, we can say that the force due to gravity on this mass is mg. M in this case being the mass of this weight, g being the 9.8. And if I put it over the pulley, that is going to go and be the force in the horizontal direction. Which means when I put this here, when I let go, this is applying a force mg that way. Now, as you can see right now, this isn't moving, but I am on an air track. This whole thing is set up like an air hockey table. There's an air supply over there, I'll turn on in a second, and it will cause a frictionless surface. Right now, friction is keeping it from moving. And the last thing I want to point out are these two photo gates. So if you notice, the flag here has two teeth. What is going to happen is the photo gate is going to measure how long the first tooth goes in and how long the second tooth goes in, giving me two different distances for over time at each photo gate, which means at each photo gate I can measure a velocity. And if I measure the velocity at two different points and figure out the time in between, I can get an acceleration. And that's how we're going to get acceleration. Now I'm not going to show all the trials today like I didn't last time either. I will be giving you the data, but I just want you to see how it's run. So here's the general idea. Let me take off the mass first. And I'm going to turn on my air. And then once the air is on, I will apply my force. Once again, whoops, by just hanging this mass. And so I just let this go. And there you go, it accelerated through. I can get the acceleration right off this timer. And once I have that acceleration, I can figure out for what this mass, what was the acceleration. I'll then repeat this for various masses. And we can make a graph of F versus A. That's only part A. I'll come back with part B in a second with another video. So for part B of this lab, we'll basically do the same thing. We're going to have the same force horizontally, but what we're going to change is the mass of this coat. How we're going to do that is we're going to take these two weights and add them on, therefore increasing its mass by about 0.1 kilogram, 0.101 to be precise. But other than that, our process is going to be the same. I'm going to put this here. And I'm going to recode the data, just like before. Nothing else changed.